Hi everyone, this is example number 1 from the camera tutorial series. The idea being we will measure some real world parts. In this example we'll be measuring this encoder spacer. So it's only 0.8 millimeters thick and it's soft plastic, flexible, very difficult to measure with the touch probe. It also has some very small radius, so it's a perfect example of when you would use the camera. So let's dive in. This will be example number 1. Firstly, let's switch over to the camera. So probe options, camera, manually change. So we will remove the probe head, connect the camera, set the probe head somewhere safe, and then OK. The camera now switches on and we should be able to see the software there. So the first thing we don't want to do is to try and fixture up the part. So if we want this to be a repeatable program, we need to be able to set this in the same place each time. So we fix that somehow by using the fixture plate and keeping the reflective plate located in a set position via these 4 spigots. So now all we need to do is a way to be able to locate this via a fixture and then remove the fixture so we can scan the edge. Very simple design. This is just one of the Aberlink fixture plates, and if we set this in the corner, we can locate the part into that corner and then remove it. That will keep that in the same place every time. So just to show you that once more, if the part is floating free, set something in the corner that we can repeat. We slide the part into that corner and then we lift that out of the way. That will repeat every time. So the first thing you'll notice is the part does not fit within the field of view for the camera. So what we need to do is set a scan area to pick up on the entire part. This lets us see the entire part on the screen in one go. We can then pick off measurements and the camera can execute them. It's very difficult to do this without seeing the entire part on the screen, and that is why we will use the scan area function here. Now sometimes, to not waste a lot of time scanning a huge area, what I like to do is go to the bottom left hand corner of the part, which we are now, then also drive over to the top right corner, so that would be something like this, and wait. And the idea is if we roll out, we can see the box we need to set for the scan area. So now we will click scan area and we'll left click down here and then click here. So that's 2 left clicks to define the scan area. The camera then breaks that up into small sections, and you'll see now the camera stepping along and grabbing the image of each section, and it saves that image to the screen so we can see the entire component in one go, making the measurements a lot easier and a lot more precise. So we let this just scan through this scan area section by section, and while this is scanning, it's worth having a think about how you will reference the component. So you still need to define the degrees of freedom. The only difference with the vision system is it's 2D. So we don't need a plane. There is no plane measurement in the vision system. So we need an origin. This is a circle or a point, and then a line to do the rotational alignment. In this example, we will use a line and point. The point will be constructed at the corner intersection, and we'll use the top left hand corner. So it will be a line along the top, a line along the side. First line will be a reference, and then we'll construct a point to create the origin in the top left hand corner. So that scan window is complete now. We can now look to get some measurements done. So firstly, we need to decide on the measurement method. This part is always going to be edge detection. It's very simple. There's no other options on this. It's always going to be edge detection. And we can either decide to use the individual features or auto select feature. It's personal preference, completely up to you. The only things that won't work is one click feature and all edge points. These only work for the field of view, which obviously this is multiple fields of views in the scan area, so these features will not work. So let's try auto select feature, and we want to get this line measured first. So line, scanning edge, that goes and executes the command, and it will step along as it goes, picking up on the entire scan, and this is going to be a reference. We then need another line, so 1, 2, line, camera goes and executes the command, scanning the edge. Now the rule system does not allow 2 lines as a reference, so we need to hit the green tick here and then construct a point. So point, construct, where the 2 lines meet, and set this as our origin. So XYZ 0 with the rotation being done by the top line. That is now the reference system complete. We can now look to continue measuring the remaining features and then dimensioning them. So let's go through and pick up the next feature, which will be this radius. So 1, 2, 3, scanning window, green tick, line, 1, 2, 3. It has to move to pick up the remaining edges of the line. And then green tick, just redraw that. Radius, 1, 2, 3, green tick, line, 1, 2, green tick, radius, 1, 2, 3, moves to execute the command, green tick, line, 1, 2, 3, moves to measure the remaining feature, green tick. This is a solid radius, so we go 1, 2, 3, there we go, green tick, line, 1, 2, green tick once it's complete, which it is now. Radius, 1, 2, 3, line, 1, 2, radius, 1, 2, 3, green tick, and then to finish off the outside profile, 1, 2, 3, moves to execute the command, and that is the outside profile complete. To finish off, we will go in and measure the inside profile. So 1, 2, scan, 1, 2, 3, scan, 1, 2, 1, oh, clicked a bit too early there, 3, scan, 1, 2, scan, 1, 2, 3, scan, 1, 2, scan, 1, 2, 3, and scan, 1, 2, scan, 1, 2, 3, scan, 1, 2, scan, 1, 2, 3, scan. And that is now the full component measured. We can now dimension and then run the program back. So now we can look to dimension. You might notice with the camera lines stretching further than you measured them. So just while we're on the topic of this can be addressed in settings and display and max extension for intersection 0.5. So this is if any lines are within 0.5 millimeters of each other, the line will automatically extend. You can try 0.1 and apply. And when you remeasure it or rerun it, you'll notice it doesn't tend to extend as much. So you can sometimes have this issue. It doesn't actually affect the measurement of the feature, but yeah, just be wary if you need to display it a little bit better on the screen. That's how you do it. So now we can get some measurements. So let's just get the width. So we'll call this width. I don't have an engineering drawing, so this is just for an example. We've then got the length. We'll extend that to maximum. Handle width. There we go. Internal pocket. Length 1. And you get the idea. Again, as I've mentioned, measuring small radius like this, little 2mm radius, even these internal radius would just be very difficult to measure, especially given the width of the part, so the camera picks up on them no problem. And now we have the dimensions complete, we can look to run the program. So this is now a fully functional program, so we can press inspection and play. Do you want to save it for SPC analysis? We'll say no. And you'll see, if I turn the throttle up on the machine, the software is now executing the measurement routines. So this will cycle through. And again, just like any touch probe measurements, as the features are measured, the dimensions will show the actual size and a pass-fail limit. So anything that's failed will go red, anything that's passed will go green, and anything that's within your warning limit will go orange. So I'll let this complete. You can see the measurement routine once the program is created is a lot faster than the building of the program. This is no different to using a touch probe with contact measurement. And you'll see here a few more measurements to go. And you'll notice it picks up on measurements within the field of view a lot faster than when it has to move and stabilize. Almost complete. And that is the program ran. And it functions exactly like anything else. We can get a report just like we can in the contact measurement mode. So run reports, and you select your options in here. tabulated dimensions, generate report here, and that works exactly the same as the standard software. Just to highlight the idea of the fixturing, if I zoom in on the fixture plate now, you should hopefully be able to see if I have, a batch of a few of these, I can quite easily, if it wasn't so flat, quite easily remove one. Say I've got a batch of them, and I can easily set the fixture plate up. So I've removed this one, I slide this one into the corner, lift this one out of the way, and if we press play now, the camera goes looking for the edge, and once it has the reference system, so it's exactly like a touch probe, if it can find the reference system okay, it can skew the remaining measurements via the origin and rotation. And it executes exactly the same. There we go. And it continues to measure just as it normally would without any issues. So this is just proving out the fixture idea and how to make repeatable programs for batch work. So finally, the last thing we're going to cover is if the part completely moves or you have to reteach the position. So this could be because you don't have fixturing, so every single job is moved, or the fixture plate entirely or backlit plate could also have moved. You run a batch of 10 with this setup, but then a year later you get another batch and it's not going to be in the exact same place. So you don't have to completely redo the program, the part's moved. All we need to do is manually teach the reference features. So with this, we'll go into program details. This is the little flowchart icon here, and we will say manually measure and auto remeasure reference features. Hit the green tick and press play, and this is going to wait for us to manually measure the features. So again, we will move over to the part, and the joy of this is it doesn't even have to be perfect. We just go 1, 2 and scan. One, 2 and scan. Hit the green tick. We then go on to line number 2, so 1, 2, scan. One, 2, scan. There we go, so that's scanned it enough, so we can move the camera away, press OK, and you'll see it now goes and executes the measurements just like it did in the previous routine. And even though the part's moved and rotated, the camera can find the remaining features okay and give you a complete measurement program just like before. So manually teaching the references is exactly the same as the touch probe. You manually measure them. With bigger scans like the one I just did, sometimes if you've gathered the data you think you have, you can just press the green tick and the software will automatically move on to the next feature if it doesn't do it itself. But other than that, the reference system should pick up the same, and you'll notice in the standard XY window, if we redraw that, it's the exact same program. So that is how you manually teach a part and rerun it. So I'll stop this here now because you get the idea, and that is how you manually move a part.